In this video, you and I get to take a big picture view of the concepts of HA, high availability, in a Palo Alto environment. And when considering high availability, it often takes at least two to pull it off. And that would be two of almost anything where we want the fault tolerance. So let's say, for example, we have this firewall right here, PAFW1, and we want to have fault tolerance. So to allow for fault tolerance, we could set up a second firewall. And for this discussion, let's call this HA Firewall 1. We'll call this guy HA Firewall 2. And the second firewall is going to be like a virtual twin. Now, it's not an identical twin because they're going to have different serial numbers on their chassis and so forth. But as far as the number of interfaces, that needs to match. So if this guy has 1.1, 1.2, and 1.3, this firewall also would have 1/1, 1/2, 1/3. And they would all be connected to these same VLANs, the same networks as the other firewall. So we'd connect this guy there, connect this guy there. And for the network connected to 1/2, we'd have them also 1/2 on firewall 1 and 1/2 on firewall 2 also connected to the same exact network. It would also be true for the management interface as well. They'd both be on the same network as each other. So some of the options we have for failover include using a cluster. With a cluster, we can have up to 16 devices, 16 firewalls in a cluster to provide that high availability and fault tolerance. However, most of the time, we're not going to implement 16 devices as part of a cluster. Most of the time, we are going to use a pair, and that's commonly referred to as an HA pair, a high availability pair, like what we have here in the diagram. And with an HA pair, a high availability pair, we have some options regarding how we're going to deploy them. The most popular and most simple method of deploying these firewalls to support each other for high availability is a method called active-passive. And with active-passive, one of these two firewalls, not both, just one, is going to do the active job of the data plane traffic, including enforcing the rules, the network address translations, the policies, forwarding traffic, keeping track of sessions, all that cool stuff that our next generation firewalls do. So let's imagine for just this discussion that this guy is currently active, and then the other firewall would be passive. And if the passive firewall determines that the active firewall is not okay, which in technical terms would be a failover event, then the passive firewall could become active and start supporting the data plane traffic. So the client may not even be aware that there was a problem or an issue or a failover event that happened. All they know is that, hey, I've got connectivity out to the internet or to wherever they were sending traffic that was going through the firewall. And that's the benefit of having high availability in an HA pair, is that we can have a single fault in the network, and yet it can be transparent to the users. They can still have their functionality. Now, one of the questions might be, well, what would be, a failover event? They are customizable, but here's generally speaking, what could trigger a failover? We could have an interface fail. So maybe gig 1/3 up here on firewall 1 fails, and as a result, the other firewall says, oh, I'm going to take over because you're in trouble. Another failover event could be a monitored path. So let me go ahead and take our active firewall, put him back in business for a moment. And here's how a monitored path or path monitoring can work. Let's imagine this firewall has a default gateway of .1. With path monitoring, it can go ahead and ping periodically, like every 10 seconds, every 30 seconds. It can ping that IP address and hopefully get a response back. And if it's doing that monitoring and it doesn't get a response back, that's another element that could trigger a failover event, where firewall 1 could say, hey, I can no longer reach this path or this destination. And as a result, firewall 2, you better take over. And at that point, firewall 2 would then take responsibility for the data plane traffic. Another item that can cause a failover event is heartbeat. So these firewalls use heartbeats, little ICMP messages, to check on each other, and if they don't get a response back, that could trigger a failover event. Another option that can trigger a failover event is health monitoring. And with health monitoring, if the active device identifies that there's a critical system component that's failing, maybe it's the motherboard or something else critical that's part of the health monitoring, it could say it's in trouble, and then the other firewall that was currently passive could take over the active role once again as a result of a failover event and continue to forward traffic over the data plane. So that's with active-passive. Now, the other option is active-active. And with active-active, what it implies is that the firewall 1 is forwarding some session traffic and firewall 2 is forwarding other session traffic. So they're both supporting unique or different flows of traffic from the users going through them. And if there's a failure of one of those firewalls, the other firewall will take on the entire load. And as cool as active-active sounds, it is a bit more involved to actually set it up and get it working correctly. And that's why most companies who are implementing high availability pairs are going to opt for the active-passive option. And if we're doing active-passive, another great question is who? Who is going to be active? Who's going to be passive? And one option that we can configure to control that is priority. And when you think of priority, which is just a number, I'd like you to think of golf. You might say, Keith, why golf? Because in golf, the lower score is a better score. And that's how priority works with HA on the firewalls. So if we have firewall 1 with a priority of 75, and we have firewall 2 with a priority of 125, a lower priority number is considered to be best or better than a higher number. And one other element I want to share with you regarding priority is this. Let's imagine that firewall 1 has a priority of 75, and that firewall 2 has a priority of 125, and they both came up normally. Life is good. They're all synchronized and ready to go. And firewall 1 is the active router, and firewall 2 is the passive router. Then there's a failover event, one of these elements over here on the bottom right, and firewall 1 gives up that role, and now firewall 2 goes active. Now, here's the question. When firewall 1 recovers, maybe there was some glitch or a hiccup or a cable got disconnected for a moment, when it comes back up online and it's all ready to go, do we want to have it just flip over again and change that back to passive and change this guy back to active? And a lot of companies don't, and I'll tell you why. If there's a failover event or some event that happens, we want functionality, but we also want a chance to investigate what the heck happened, because we don't want it to happen again and again and again. So a lot of times we don't want automatic failback to the original device with the highest priority. And so by default, it won't. It'll wait for you to go ahead and investigate. However, if we want to tell the firewalls, listen, firewall 1, you've got a better priority of 75 than 125. So if you come back online, just go ahead and take it over. Just tell your partner, hey, I'm here, I'm back, I'm ready, I'm going to take over again. And if we want that to happen automatically, we are going to enable a feature called preempt. And what preempt basically says is, hey, if I've got a better priority and everything's good with me, I'm going to take over the active role. Even if you were doing it 5 minutes ago, I want to take it over now. So we'd want to make a conscious decision regarding whether we want that feature or not. Now, one of the challenges that we face is we may have a user, like user 1, who's currently sending traffic through the firewall, the active firewall, and then there's a problem, and there's a failover event, and as a result, the other firewall that was passive then becomes active. Well, if Bob has an active session that was going through the firewall, is he going to just lose his session, has to start over? What do we do about that? Well, the cool thing is we are going to replicate the config information between the active and passive firewalls, and we're also going to replicate the session information, and that's done over HA links. So in the next video, I'd like to talk with you in more detail about those HA links and how they're used to replicate both config and also session information between the two devices in the HA pair. So I'll see you in the next video in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.